I'm very happy to present two colleagues from Berlin tonight. One, Undine Lieberwirth, is a direct colleague from the Digital Classicist seminar and is working at Topoi, at the FU department of Topoi, and is responsible for GIS and database systems for basically all the Topoi fellows and helping them with their technical issues. She studied prehistoric archaeology and classical archaeology at the Humboldt University, and, which probably was very influential for her, GIS and spatial analysis and archaeology at the University College in London. And from this time, at least, her focus and interest in GIS systems and all the different possibilities has arisen. She has long been working on 3D issues in GIS systems and is still working in that, and as part of that project she has been part of the excavation team in Ostia, which gives the link and the relation to a second colleague from Berlin. His name is Axel Gering. He has a very new professorship at the University of the Humboldt University. His background is classical archaeology and ancient history, which he studied in Munich. And then he had some time research fellowships, especially in Rome, because his scientific interest is very much in Ostia and issues related to Ostia and on a wider scale about urban spaces in the Roman imperial period and late antiquity. The aspect which links both of these persons, and that's the reason why they're here, is the interest in methodological approaches about digital documentation of excavations and of the benefits and the trade-offs and the possibilities in terms of time and money, but also in terms of methodological approaches for archaeology. So I'm very happy to have them here today. 3D GIS in archaeology, voxel-based depiction of archaeological stratigraphy in a microscale analysis. As usual, we have the talk being recorded and then the formal, official discussion, so to say, which will be also recorded, and after that we have some informal discussion and gathering with some wine and drinks afterwards for those who are interested. But that's the point to hand over. I think Undine is the first to start. Thanks very much.
So, thank you very much, Felix, for this nice introduction. Thank you very much, everybody, for coming. And the last thank you for the organizers of the Digital Classicists in Berlin for inviting me. This is not a joke. As it's already my second try to get a speech here in front of the Digital Classicists, and it's a tough review process, I have to admit, and that's why I'm very happy to present now my latest research results. So let's turn to the presentation today, 3D GIS and Archaeology, a voxel-based depiction of archaeological stratigraphy in a microscale analysis. This will be my topic, the first part of this presentation, and Axel Gering's part will follow, and he will extend this scale to a macro scale perspective. 3D reconstructions in archaeology and historical building research are mainly used for reconstructing the past. In this study, we tried something different, to reconstruct the present. The aim of this study was to create a 3D excavation map, including all documented data and post-processing information for a better understanding of archaeological remains and other features which are detectable and measurable, and provide a geodatabase for further statistical analysis. Therefore, the environment of a 3D geographic information system was chosen. The idea came up already in 2007 when the first excavation reconstruction in 3D GIS was created. The reconstruction depicts one trench of the 1970s excavation at Acroterion in Kisera. It consisted of 13 layers and 3 building structures, here in white. We were able to reconstruct solid volumes of archaeological stratigraphy, so the model can be cut at any place and will therefore provide an insight into the whole structure. The 2007 model depended only on the excavation drawings of sections and ground plans, here on the left-hand side. From this information, a complete and precise 3D reconstruction of Trench 4 at the site of Acroterion at Kisera in Greece was created, including the documented archaeological features and layers. But this time we wanted to test the strength of the 3D model with real digital excavation data. This is the final model of Trench 1 in Ostia, Antica, showing geophysical data as voxel and stratigraphical top and bottom surfaces as 2.5 dimension models. The voxel model has the advantage that one can cut it at any point. This offers the opportunity to show information at points where no data was taken. In this example, we can compare geophysical 3D data with the course of archaeological stratigraphy. According to the experiences from the 2007 prototype, some requirements were created before we started the excavation in Ostia Antica. Firstly, the site should have a considerable amount of stratigraphy. Secondly, the excavation method should be single context recorded so that the course of the stratigraphical top and bottom surfaces is measurable. The idea was to perform a precise documentation of each stratigraphical surface. Thirdly, the whole application should be applicable for common archaeologists, not IT specialists. Therefore, the use of most common hardware and software was desirable. The methodological research question was therefore to find a way to transform all excavated and documented data into a 3D GIS and to find out what kind of analysis is possible within this system. We also wanted to go further than in 2007, including not only archaeology, but also all other information gathered on an archaeological site. Therefore, we plan to include geophysical data as well as pedological data. Fortunately, according to our methodological requirements, a cooperation with Professor Axel Gering between the Excellence Cluster Topoi, the Humboldt University Berlin and the University of Kent could arrange an excavation at the site of the main forum in Ostia, the antique harbor of Rome. The site was located at the western porticus of the main forum, still visible as a paved pathway, flanked by the column shafts, here on the left-hand side. This pavement has never been lifted by excavation nor otherwise investigated. And since this area forms the oldest and central part of the city, we expected a deep stratigraphy, perhaps even down to the beginning of the city's foundation. So the first requirement, several amount of stratigraphy, should hopefully be fulfilled. And since it is obligation in Italy to excavate in single context recording, the place was perfect. The excavation took place for 5 weeks in summer 2011. At first, the marble stone slabs were documented and lifted so that the geophysical prospection could be applied, at first in a rough resolution. Then the final excavation trenches were selected according to the geophysical results at 2 places. The example I introduced today, Trench 1, here area A, which was investigated by GeoRadar a second time with a higher resolution. Now the digging could start. Every time after the removal of a stratigraphical interface, the top and bottom surface was precisely measured by a 3D laser scanner or later with the structure for motion method. In the next step, the outline of the surface was documented as a 3D polyline with a total station. Each archaeological find was also measured and on the fly documented via a total station with the attached software TachyCAD and MonoMap, a database structure for all documented features. Trench 1 consisted of 3 layers of stone pavements with antique backfilling in between, which contained a high amount of ceramic vessels and carved stones. So in order to document all these detailed surfaces, a high-resolution measurement grid of 1 by 1 centimeter for the laser scanning was chosen. However, when the laser scanner showed its limitations by documenting deep holes, we used additionally the structure for motion method. As we expected, the stratigraphy was of high amount. For Trench 1, we got 14 layers. Additionally to the archaeological documentation, we took also 380 soil samples in a uniform 3D grid of 20 centimeters, unregarding the stratigraphical order. Here these balls in this 20 centimeter grid, and here in a section view. The post-processing of all documented archaeological material included the cleaning, registering, and georeferencing of the scanner point clouds and structure for motion points. And finally, its combination with the AutoCAD vector data in a GIS. The database structure of MonoMap could be imported without losing information. The same was true for the point clouds. These were imported as ASCII files with the coordinate information and color value as RGB, unregarding from which data source they came. The point clouds of the top and bottom surfaces got an additional column with the layer number. Furthermore, 9 chemical elements of the soil samples were analyzed, their values added as attributes to the location of the samples, and their element value interpolated in 3D space. The results are voxel volumes, so here these bulbs, the gray ones, 3D objects, each containing 1 element value. By adding voxel concentration centers of pedological data to the archaeological surfaces, both can be analyzed and compared together in a 3D space. By cutting the concentration areas horizontally, the highest values can be revealed and spatially localized. Finally, the 3D interpolation of the GeoRadar reflection amplitude values across the trench allows the comparison with the archaeological and pedological data as well. And by adjusting different threshold values, high and low reflection results can be explored throughout the whole trench at all places and compared with the archaeological structures. So here on the right-hand side, you can see a solid structure, and when we go back, yeah, this is this structure we excavated. So this is the bottom surface of layer 8, for example. And this can also be seen here in this voxel structure by adjusting a certain threshold of the GeoRadar results. The GIS environment also offers several statistical descriptions, for example, area and volume information here on the left-hand side, mean and range of the interpolated values, and one can execute queries according to the attribute table information like in 2D GIS. But what is actually a voxel? A voxel is the abbreviation of the word composition of volume and pixel. So in fact, we have an extended 2D pixel in the third dimension. The 2.5 surface shows a draped surface without volume information, here on the left-hand side. And the 3D model contains also information underneath the surface. Like in 2D GIS, the 3D volume can be calculated, for example, out of vector points within a 3D space. But in 3D, it is not the elevation value which is interpolated, it is a further descriptive information expressed in a value. The interpolated result creates voxel or 3D raster cells with probability values between known areas. This representation is very suitable for fuzzy borders we often have between stratigraphical layers in archaeology. Voxel models are commonly known from medical magnetic resonance tomography. These voxel models can also be cut, but I must unfortunately disappoint you, the inside of my brain is not the topic of today. Coming back to our Ostia model, according to our final result, the applied digital documentation methods have been proven applicable in the workflow for getting a 3D GIS model. The AutoCAD vector data could easily be exported as GIS shapefiles. The used monomap database records were attached as a shapefile attributes. The combination of the laser scan and structure for motion point clouds worked perfectly. The precision and accuracy of the structure for motion point clouds is very satisfying. Sometimes they are even more accurate than the laser scan. This topic and the comparison between both methods has already been discussed. But according to the workflow and handling, both methods have, of course, their advantages and disadvantages. From the classical archaeological equipment, the use of the Harris matrix diagrams was very helpful by dealing with 14 layers. Additionally, during the post-processing, the matrix could even be extended into more detail by using the advantage of GIS, by calculating difference maps between raster surfaces lying above each other, a kind of vertical querying. Turning to the archaeological results, despite their small dimensions, the two investigated trenches represent the parts of the most interesting places of the forum. We will hear more about it by Axel in the second part of the presentation. So what else can be done with the data at hand? Besides the open task of calculating a second 3D GIS model of Trench 2, for which we have the same data as for 1, but found much more archaeological finds and objects, we expect more precise dates of the archaeological features for a solid interpretation of the development of the Ostia city center between the 2nd and 6th century AD. Finally, we hope that at least in some parts between Trench 1 and Trench 2, we can extrapolate 3D information in order to obtain a predictive 3D model of the unexcavated parts. Concerning the methodological perspectives, there is still something what can be done to improve the model. Spatial statistics is one of the main analysis methods in common geographic information systems. In 2 dimensions, spatial density analysis, for example, helps to find clusters for making statements about distributions of finds, objects, or even settlements. But if we have distribution within a 3D space, the pattern might look differently according to the point of view. To explore the distribution of finds within the stratigraphical layers is a further aim we would like to achieve with this study. We assume that the detailed analysis of the finds' 3D distribution reveals more details about the development, destruction and resurrection of an important part of the city of Ostia. Finally, since photographs are very vital for archaeological interpretation, their integration into a 3D GIS still remains an important task. However, at the moment, there does not yet exist an exchange format between structure for motion or laser scanner software and GIS. But their development might only be a question of time. To conclude, looking at our aims and requirements from the beginning, we think the prototype of digital recorded excavation data provides an environment for nearly all archaeological and natural scientific data together, as long as they have a location and expression value. In summary, it is possible to extract information even at places where nothing was documented, displaying and analyzing statistical information, executing queries and selection in 3D space to finally create thematic 3D maps. We think that the improved 3D model of 2016 can help to understand the whole nature of an archaeological site and might be a good starting point for reconstructing the past. I would now like to hand over the microphone to Axel for the second part of this presentation. And so far, I thank you very much for your attention.
Ladies and gentlemen, thank you for the invitation first. And as promised by Undine, I would like to add some aspects which are coming obviously from an archaeological point of view, and to explain in what context we tried, because it was still an attempt to improve excavation and documentation techniques at this time. And since 2011 we had quite close contact, Undine and me, and so we always had a discussion, ongoing discussion, how we can improve the interpretation of archaeological sites by the help of modern documentation methods. Okay, here we see a little picture executed by the aerial photography done by an octocopter of the cooperation partners of the Freie Universität, HP TAM. And we can see here very well on the left side of the huge Capitolium of Ostia, the portico Undine already has described in its extension. And the Capitolium, just for information, is roughly 17 meters high preserved. That means it's a reasonable monument in the landscape, and it was always visible during the centuries. So basically our work is a continuation of centuries of excavation history, and therefore I would like to go to the next slide. The excavation history for Ostia is a very specific and problematic evidence, because we have an excavation period, which is called a scientific excavation, because for the first time stratigraphic information was documented in a very rough way though. And this is the period from 1910 to 1924. And this so-called scientific re-excavation was based on non-documented refill material. That means we don't know really the original provenance of the material most of the time, because it could have originated from late antique lime kilns, which we still discover nowadays, until the first not documented excavations from 1801 to 1804. Just to keep this in mind, Ostia is a very hard case. If you are not really into getting into the archive, this causes lot of a problem to the interpretation. This is the status quo of our excavations until 2016. These are surface excavations. Basically here we have a grid of 5 times 5 meters, so you can see it's quite a substantial area covered. Basically until this campaign we made a surface excavation of all porticos and the big plazas of the city center, including other forums, so-called fora or the forum-like spaces like the Foro della Statua Eroica here in the plan with FSE. In the middle you can see the forum. Of course this is not possible to do alone, as already mentioned by Undine. Topoi was in 2011 and the Fire Instead was in 2011 a very interesting and new cooperation partner. Since this time we already had contact to Aarhus and University of Kiel, and nowadays also a Hungarian university taking place as our cooperation partners, and most of the time we were sponsored by the Gerda Henkel Stiftung and for a longer term perspective now by the Stiftung Humboldt-Universität, which I of course like to thank in this occasion. Our main aims for the project, which is designed until 2022, is to document Ostia's late antique center in photomosaics in 3D. We like to also continue with geophysics, and based on the geophysics results we continue doing trenches, and we like to put a new light on more than 900 years of building history in the city center of Rome's first colony. And a next side project since 2 years is the reconstruction of all marble decorated buildings of the city center, of course, because roughly in marble deposits we found more than 12,000 single pieces of marble, mostly decorated, which is also seen by the sheer number quite big task for the next year. So now to 2011, the old history of our excavations. I can hardly remember, a little bit I can remember, unfortunately. We started a few weeks before Undine arrived with her team. It was a task to clean the first late antique surface which we could still find in this eastern portico, in this western portico west of the big Capitolium, which you can see in the plan. And then, like Undine already mentioned, 3 trenches were selected, and they were completely excavated by our cooperation partner Undine with the Topoi team. Undine already has shown trench 1 in all the possibilities. We continue now with trench 2, of course from a not competition like archaeological point of view. That is just to have an impression, the first week's task. We did some surface cleaning, and this already was an interesting part, because in this little stratigraphy above the slabs we could detect traces of more than 200 years of digging history, which is mostly undocumented, of course, and also history of modern tourism since Mussolini's time, which is also maybe an interesting part of archaeology inside archaeology. Roughly 20 until 50 centimeters below the former surface level, we found a quite big part of the antique pavement, which is, as can be seen, obviously partially robbed. But even if the slabs are robbed, we found a very well preserved mortar bed, or several mortar beds. That's a view from the Capitolium to see the most interesting northern part of the portico. Why did we choose these trench locations? Undine already mentioned geophysics, also old plans in the archives can help in this case. All trenches had something in common. They had irregular surfaces. There were holes or caverns with a later fill, and so they are interesting for archaeological questions because they can offer dating evidence for collapse and phases of late repairs. And secondly, our trench 2 can also be related to predecessor buildings or building phases, which is in this case a street, which is quite obviously in the old plane. It runs underneath the big Capitolium and is a continuation of the street, which was later rebuilt in another shape to fit in the new Hadrianic Capitolium. This is now the Topoi team, freshly arrived at Trench 2. And this is a Trench 2. What we can see quite obviously is a surface we see in the middle, surrounded by this red line, a hole or cavern, which I might call it, consisting of a fill, a big, huge filling, with a high ceramic density, but also on the surface mixed with mortar pieces. And this ceramic density is also already quite possible to see with some handles of big amphorae and roof tiles. This is a graphic already published by Bernhard Fritsch, also part of the Topoi team. We can see quite well three, let's say, steps on the way down. The first one on the top, you can see a surface level with the mortar pieces and still the earth of the first cleaning. Then we have, secondly, in the middle, quite well visible, this dense ceramic fill in the gap between the mortar bed, the original mortar bed, but obviously of a late building phase. That is quite important because after removing all the finds from this cavern, we reached the original preparation level of the 2nd century AD portico, which is obviously quite a lot deeper. This is now the simple 2D graphic of context plan and shows this cavern and Trench 2 in its context. We can reconstruct quite easily a destruction event. Obviously, you can see concentric cracks in a lost pavement slab. The slab itself is not preserved, but we can see these traces in the surrounding mortar bed too. A local pavement was obviously damaged, and this damage was caused by two, let's say, on one hand, by two factors. On one hand, by a cavern or a hole underneath the pavement. This kind of cavern could be explained by erosion processes or earthquakes and so on. And it's on the other hand caused by heavy objects falling on top of the pavement. And this can be still in the process of decay, and in our model could be imagined by capitals, big architraves or ceiling elements. This is of course hypothetical, but the way the cracks run to the concentric middle of the cavern show quite clearly that something really heavy was once falling on that area. So now this could have been the reason why there was some kind of repair, and now we want to see what's underneath. And then the filling of the cavern was analyzed by the Topoi team. At first excavated. Our analysis since this time was to draw the pottery, to also extend the possibilities of pure drawing, also by photographing and trying to get some proofs of the material for content analysis. The status quo of the research is that the ceramic is now almost finished, processed by Philipp Kobusch from our University of Kiel cooperation partners, and it will be published in the next interim, where we may also publish altogether with the nice results of the computer possibilities. And Silvia Polla, also from the Freie Universität, contributes archaeometric data and the content analysis, mainly the question what was inside the amphora, oil and wine, or not, as part of her study project. And so far, as we can judge by now, we have a quite wide chronological range, but which fits quite well together. And it heads up to the second half of the 5th century, if not to 500 AD, more or less. I would say history repeats. We have a similar destruction evidence at Trench 3. This is here the original picture when it was cleaned by the Topoi team. We can see on the right side very nicely a broken slab, partly sunken in direction to its middle. And we have on the left side a preparation level for a laid pavement, which is seen to the left bottom. So two very typical evidence, parts of an evidence, which I will continue to show in other examples. We have a lot more of these concentric cracks and portions of slabs which were obviously hit by heavy objects during an event of collapse. And this is a detail which shows also something very specific. It shows the drastically sunken mortar bed of an older pavement, which has very specific cracks, and we had already some seismologist experts, and therefore we want to continue this as an actual new side project of the Ostia Forum project to find out if these earthquake events can be traced also more widespread in the context of the whole city. And this mapping of all these traces of earthquake is now this project with Laura Piccioli and engineer Giovanni Cangi from the Tor Vergata University in Rome. And it will be starting from the evidence of this year for the next 2 years. We have a look if we can put the earthquake evidence in a bigger context. This is already shown, this drastically sunk 2nd century mortar bed. You can see it's almost at the same level like the modernly re-erected columns, and then it falls really much down towards the end of the trench, more than 20 centimeters. And this difference makes quite clear that repaving the portico, it's necessary to be re-leveled before to relay the old or new pavement slabs on top. So history repeats again, as I may say. Similar evidence of this cracks and re-leveling we have elsewhere in the same portico, which is maybe not a surprise, but we also have it on the opposite area, the other portico with the so-called 3 rooms here. I showed just shortly the example, which is interesting. We have an older part of the pavement here surrounded by the red lines. And slabs in this part of the pavement show partly massive cracks, also with this specific pattern of concentric cracks. And they are partly sunken into a former middle. And they were replaced partly by a new pavement, which is also clearly visible because it's based on a new mortar bedding. And the pattern of the pavement itself changed too. On a massive point, spolia, that means reused marble decoration elements, were used either upside down or in this case even upside up. And one example I showed here, marked here with a little red arrow, which is a part of a nice decoration of the 2nd century. Good, going down south and looking into a wider perspective as promised. We have phenomena of destruction and collapse also in the south end in the forum and elsewhere, and still some open questions. Is it only one catastrophe? Is it really an earthquake? And when did it happen? Now we go to the southeast portico, called MFP, Main Forum Portico. This is seen from above during its first excavation. And that is the pavement in this portico after its full excavation. And during the campaign of 2011, we already continued to do also there some trenches to prove, verify, or falsify the results of other trenches. For example, in most of the trenches we have a huge amount of coin finds. And our coin finds range basically from the 350s AD to the 430s AD. They are processed now in cooperation with the University of Naples, and we also like to publish this in one of the next interims when we get enough sufficient space to do so. And dating with coins has big advantages because of the sheer number. We have more than 400 significant coins in the porticos, and this allows us also to do interpretation on a representative scale. This is just one example of a coin around 350, Constantinopolis, which was found in the upper layer of this repaving of the main forum portico. It's quite interesting to see the way how this pavement was sunken. I would not from the beginning on do a similar interpretation for sinking by simple fundament problems or earthquakes, but this has to be judged in a single case study in any case. And but what we also like to do in every case is to have evidence, analyze the evidence of the mortar bed underneath the slabs and the relaid slabs. And so in lots of cases we find dating evidence, ceramics or, like I said, coins underneath the latest mortar beds and underneath the repair slabs, which allows us to paint or document a distribution card of repairs. And so we are able to judge which parts of the pavement of the forum was repaired at what time. We also had some famous repair slabs, that means slabs which were integrated in an already existing pavement on a higher mortar bed. Like here, the repair slabs with inscription. This is an inscription from the 1st century AD. And it was reused upside down with a not representative backside showing up as part of a pavement. And underneath we had this nice surprise to find dedication inscription to the numini of the house of the Caesars. This is our portico, MFP, with its original vaulted ceiling, and we found in the latest areas of repair the collapsed ceiling parts, fragments, reused as a simple fundament filling. We also see that it's a very simple way how to re-level and repair in the latest times the forum porticos. Basically the same which is true for the pavements is also valid for the walls. Also looking closer to walls shows mostly clear lines where original walls of the 2nd century stop. Then we have repair, and then we have partly re-erected, in late antiquity, re-erected walls on top, and of course modernly reconstructed wall parts on top again. So that means reading the walls also takes a lot of time, but it's an interesting part for the interpretation. And also here we have, for example, between the original 2nd century walls and later walls, we have a clear line where the destruction can be traced and where the repair of later times can be traced too. To make it more clear that this, based on all this evidence, our construction for the portico itself, it's a 2-story portico, and it has not the full extension to the columns which we see nowadays on the forum. And after this collapse catastrophe, the whole portico was re-erected in the way how we can see it today. That means with columns, probably with a wooden architrave, because we didn't find any parts of a well-executed stone or marble architrave. And this is obviously a quite late repair of the forum portico. That's the reconstruction. That's the last building phase, dated around the middle of the 5th century or later, according to our find analysis. We have some historic earthquakes. That's a long ongoing research, also in Italy, and there are two important definitions. At first, Ostia is a part of the scenario of Rome. Ostia is still considered to share its geological faith, I wrote here, with Rome. It's on the same mapping 2B it's the same zone when earthquakes, like the nowadays actual earthquakes also, had their effort on Rome, they have roughly the same effort on Ostia. That's important to know, because most of the, from antique written sources, recorded historic earthquakes are obviously only recorded for Rome itself. But it means these can be considered almost equal to the Ostian situation. And we have in the, as far as we have now evidence of earthquakes, we have a rough timing of the repair, and we have, interesting enough, evidence of earthquakes by written sources with an epicenter in the Apennine, which is no surprise, that's a very big and close epicenter. And one of the strongest earthquakes in historical times, Roman times, late Roman times, is the one of 443, which is recorded with 8 until 10 on the Richter scale. The other, this is another earthquake, it can't be decided which date, and this is a much, much tinier scale. So in our historic earthquakes we have one candidate. Of course, from a legitimation it is so far not possible to judge exactly. We have to go on. Back to the forum, a few to the south, we have some prominent earthquake victims, and in this case it's a whole temple. This is the so-called Roman Augustus temple in the south of the forum of Ostia. That is a map which is a summary of long-term study which I already studied 2003. That is all buildings which show clear signs of collapse caused by earthquakes are marked here in brown. The different coloring of light brown and darker brown is just depending on the dating. What I just want to say with this map, it's quite clear that our representative city center of Ostia Antiqua in late antiquity suffered a lot by earthquake-caused collapse. And what is also obvious in this map, green are marked the areas which were repaired immediately after or in the decades after the event. And that shows that in the long run of the 5th century at least, a main road like the Decumanus, which is here the main axis passing this picture, was still maintained, and many buildings behind the, let's say, facade of this main axis, they were not repaired or even kept in a ruined state. I don't want to go too much into detail with this picture. There's also two areas in light purple. I hope you can judge light purple. That is a complete removal of all elements, architectonical elements, and a re-leveling. That means only two buildings were not rebuilt after the event, the seismic event, and they were completely covered with a new level of use. Let's say also in archives we can find interesting evidence of earthquakes. Here we looked for traces of collapse and did that successfully behind this temple of Roman Augustus. We see a whole, let's say this is already assembled by the early excavators, but they were found, as far as we know, the diaries, all in this area, and they all consisted of the main pediment of this temple and also of the cult stature of the Dea Roma. This allowed us in the last 2 years the reconstruction of the temple by the marble finds which we had. I already said that in this area in the Wiegand house last year, so I will make it short now, just considering the earthquake. This is what we reconstructed by the area where we found the pieces, how the collapse could have happened. That means firstly the main columns and the front part of the temple had collapsed and was removed, and the building debris of this front part obviously was carried to a very close by structure, a former portico of the forum, which was turned into a late antique stone factory, or would you say recycling factory or industries. This is also proved by many evidence. At first we have clear and interesting parts from the temple itself, like this is a roof tile, marble roof tile, and these marble roof tiles were cut with a stone saw in 2 parts to gain 2 new flat surfaces for new opus sectile floors or for marble wall decorations. And another part that is part of the architecture of the niches inside the temple, and this was turned into a threshold. Also a quite interesting way how to reuse marbles of the temple of Roman Augustus. It's just 2 examples for a lot of the finds we had. I already showed this one time. That was the floor of this so-called marble recycling industries, and we found incredible amount of marble cut-offs. That means several tons of material, which shows a very intensive and long ongoing recycling process here. And these about roughly 120 coins which we found in the context of this new layer, they allow us a dating of this area as a factory, recycling factory, after the middle of the 5th century. So the temple ruin, which we had in our model, and then we had a last collapse. I call it collapse part 2, and the last remaining standing parts obviously collapsed directly on the Cardo, which is behind the temple, and there exactly these pieces were found in 1924. That means altogether we have the forum in the 2nd century until AD 450 roughly, and this is the forum in the later 5th century and onwards. And now it's one of the last pictures. This is a wall of an insula, a bit distant of the forum area, and it's buried on the same level as the latest repairs in the porticos, and which were mentioned above. Compare the trenches which we already mentioned. So to the conclusion, these 3 trenches in MFE, named Forum West Portico, with their dense ceramic dating material, allow us to come to following conclusions. There are central evidence for fine dating a late antique earthquake in its last repair, and they can be paralleled with similar phenomena in the whole city. And as far as it can be judged from now, also different data from archaeological excavations now ongoing outside of the city, at the Porta Marina, I can assume, at least, it's a high probability that we are dealing with this biggest collapse catastrophe of Ostia, probably this just mentioned earthquake recorded for the year 443 AD. And by the written sources, it's quite exactly dated also for antique. Because of the distance, you would not expect that we know it was at 1 o'clock at night on the 15th of April in 443. And if you want to read more about this earthquake and the written sources, then I can recommend the publications of Guido Boni. And he also reconstructed this earthquake with this incredible strength of 8 until 10, until our Richter scale. So that means from the little trench 1 showed by Undine, I tried to come to a main conclusion that we can trace one of the historic earthquakes on a quite big scale of evidence, and therefore a microscale analysis done in a high precision like Undine did is for us a high value, because then archaeologists would not normally say this is another not usable earthquake dating by intuition. Now then it can be said with full legitimation it is an earthquake dating based on very solid research, which can be even reanalyzed easily on computer anywhere in the future. I thank you very much. I just want to show for further details you can find on the webpage ostiaforumproject.com, and I thank in the name of the team of 2011 and Undine's team for their attention. Thank you.